The first step on this problem is to find the LCD. Each of the denominators are a binomial, and they can't factor anymore because they're both linear. So I have to write each factor and raise it to its highest power. Each of the greatest power is just 1, and that's my LCD. So I want to rewrite these two fractions with a common denominator of x plus 3 times 3x minus 4. To do that, I'm going to multiply it by their missing factors. On the first fraction, we have x plus 3, and I need x plus 3 times 3x minus 4. The missing factor is 3x minus 4. If I multiply it to the denominator, I have to be fair and multiply it to the numerator. But the other thing you want to remember is you want to keep the 3x plus 1 in parentheses as well. Don't multiply that out. Some students are tempted to multiply that out to save themselves a step, but I suggest you don't because you might miss this negative when you're distributing, so I just be a little bit careful there. On the second fraction, we have 3x minus 4, and I need 3x minus 4 and x plus 3. The missing factor there is x plus 3. Again, don't forget your parentheses around any binomial numerators. So now I've combined these into one fraction with the LCD. Now I'm going to take some time to distribute out both of those numerator products. So that gives me 9x squared plus 3x minus 12x minus 4. Because there's a minus here, you need to keep the second product in parentheses until you distribute your negative. On this next step, I'm going to go back and distribute this negative all the way through, or if you want to think about it as an invisible 1, that might help as well. The denominator, that blue denominator, as soon as you've decided what it is and you've forced it to be LCD, it just comes along. Please don't stop writing that. Continue to write that every time. So then I'm going to distribute that negative, so that gets me minus x squared minus 3x plus 4x plus 12, and now I can add all of the terms in the numerator. So I have 9x squared minus 1 more x squared, that's 8x squared. On my x's, I have negative 9 minus 3, that's negative 12. Negative 12 plus 4, that's negative 8x. And then I have negative 4 plus 12, and that's 8. That does look like I have a GCF. I have 8, so I have x squared minus x plus 1, still over that denominator. And it doesn't look like anything else can factor out, so I am done. Because nothing divided out or reduced, that means that you could have also answered it in the form above it because nothing else divided out. On our next problem, we have quadratic denominators, which means I need to try to factor it out to find the least common denominator. So this factors into x plus 4, x minus 1. The second one factors into x minus 5, x plus 4. So the LCD here is one of each factor raised to its highest exponent. X plus 4, the highest exponent is 1. X minus 1, the highest exponent is 1. And x minus 5, the highest exponent is 1. So I have now found my LCD. Now I want to go back and multiply the numerator and the denominator of each fraction by its missing factor. So the missing factor on the first term, I have a x plus 4, I need it. I have an x minus 1, yeah, I need that too. But I don't have an x minus 5. So I'm going to multiply the denominator by x minus 5 and the numerator by x minus 5. The order in which you put the two numerators doesn't really matter. I'm just running out of space here. The operation between these two is plus, which means I don't have to distribute in a negative, so that's good news. On the second denominator, I have x minus 5 and x plus 4. What is the missing factor that I need to make it into the LCD? Well, the missing factor is x minus 1. If you multiply it to the bottom, also have to multiply it to the top. Don't forget to keep your x plus 31 in parentheses, please. And now I have an LCD. I've combined my two numerators into one long fraction. The denominator is going to continue to stay the same throughout the rest of the problem until the end where we might have to reduce it. And then I have to spend a couple lines of work trying to distribute this and combine like terms. So I have 2x squared minus 10x minus 7x plus 35 plus, so because that's a plus, I don't have to keep parentheses around this when I work out the second one, x squared minus 1x plus 31x minus 31. So when I combine like terms, I have 2x squared and 1x squared. That gets a total of 3x squared. Minus 10 minus 7x, that's negative 17x. Minus 1 more is negative 18x. Plus 31 is 13x, positive 13x. 35 minus 31 is positive 4. At this point, I can try to factor my numerator. So my factors of 3x squared are 3x times 1x. My factors of 4 are either 1 and 4 or 2 and 2. So I'm going to come off to the side of my paper, and I'm choosing guess and check. If you want to use the AC method, you'll probably need a little bit more paper than I'm using. So that gets me 6x and 2x. Nope, that's not big enough. Let's try 1x and 3x and 4 and 1. That gets me 12x, 1x, and that truly does get me 13, so that's plus plus. So this numerator factors into x plus 4, 3x plus 1, notice that the blue denominator stayed the same the entire time until now. Now I have a factor in the numerator and a factor in the denominator. Now that I have a multiply, the opposite of multiply is divide. I can divide these out to 1. And my final answer is 3x plus 1 over x minus 1 times x minus 5.